Okay, my outstanding friends. I was going to do a video on my good friend Marguerite over in Ireland, who has been doing a fabulous job. She's helped over 500 people with families with autistic kids primarily, because how I got into this was working with her and helping her with her son, and he's doing quite a bit better, and he was he was really in trouble, and I didn't see this about the 500. She sent me something else. She said, we just did all this stuff with this one person and it didn't, nothing worked. Stem cells, fecal matter transplant, all kinds of stuff. And I said, is everybody else doing okay? And she said, yeah. She says, not one parent I have worked with hasn't gotten results. So thank God, 500 is not bad for having one that didn't get there. Now, this was all going to be about her and her. They wanted us to do a review of a book or something. And again, I can't get deep into this. I have a lot of things going on, but I can offer assistance. And that's what I'm doing. And Marguerite she's got a really serious history of taking care of things. I worked with her to get John's digestive system working. That's the key. As you're going to see, I don't know, it has turned into a real, I call it a Mudfossil ramble. I just started talking about this, but it all sort of ties together in a manner of speaking. But it's, what it is we're made out of chemistry. And I understand the chemistry. And I understand what makes the chemistry. And what makes the chemistry is bacteria. Bacteria create enzymes. Enzymes break molecules down 100,000 times a second or a minute. They do. It's just unknown. Unbelievable what they can do. And I'm going to get into that. But I do want to make sure you understand this is primarily, where'd you go? Marguerite, where'd you go? This is primarily about Marguerite's work. And they want us to review a book and so forth. But she has a method down. She's got the son that had these, he was nonverbal, continuously stimming, shaking, all kinds of tremors, and I guess most of that is gone. And he's become verbal. And he's, the thing that really, boy, I'll tell you, yeah, this is emotional. She told me that she went to the zoo with him after he became verbal. And she had been taking him everywhere. She tried to integrate him into society, but it just wasn't working. They wanted to put him in a locked ward because he was just uncontrollable. Now, they went to the zoo again when he was able to converse. And he said to her, he said, do you remember the last time you took me here? And he's talking something about a lion cage or something. And I just dropped to the floor. All right, so this is, wait a second. I don't think I showed you the email I got from her. Because how this all started was she wants me to review a book. They're writing a book on her experiences. She's done over 500 one-to-ones. And they've all had good success. She says, there's not one parent I have worked with that hasn't gotten good results. Now, except she has this one. They even did stem cells. They did a FMT. They had that done in India. I don't know if that's a problem. But this one, so I said, wow, I hope she's not having other problems. She said, no, 500 people. And they're really she's just doing a fabulous job. I can't say enough for Marguerite. This is emotional. Okay, 12 minutes ago this came in. Glycine has now been unmasked as a game-changing discovery in depression and anxiety treatment. What is that? What's that all about? I can tell you what that's about. You're shorting out your nerve system, or you're not creating the chemistry to keep this membrane protective. This membrane right here, if it's not functioning correctly, you are predisposed to being sick. And that's what they look like in mud fossils, gigantic mud fossils. This was a membrane. It's only the lower layer. 6 feet up is the top layer. Everybody knows Tyson, who was my good friend on the west coast of Oregon, Tyson Carlson. It's Tyson's Mud Fossil Adventures. And he's got a creature out there, and I think I know what it is, but, you know, we have differences of opinion on things. But I can tell you one thing, that's a membrane. There's zero question about it. And these are these protein channels. They allow what they only can allow through there. But what do they have to have? They have to have the right chemistry. They have to have the right push to shove. Say, oh, no, 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 not you. Oh, yeah, you can come through. No, 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 not you. And that's what this does. And they're very, very complex. And they're very, well, they're not easily damaged. But what runs them is bacteria. That's what this is all bacteria living in here. That's what creates the chemistry. This is what they're missing. Glycine may be a real problem. I don't know. But maybe you're missing Clostridium, They're supposed to turn to glycine, not reactive. This is what chemistry does. This is what the issue is. And, you know, the medical industry literally treats symptoms. In my research, that's what I found. I'm not telling you to take anything or don't take anything. Don't ever, ever, ever take that away from my research. You do your own thinking. But I'm telling you right now, this is my serious voice. I have been denied access to speak of things. See, now here I go complaining. Oh, God. Okay, my friends, this is about as serious as I have ever gotten. Cancer, and is literally every single disease there is that is invasive, breaks through a membrane. This is a membrane. And this is cancer cells growing through your normal membrane layer and penetrating this layer right here. That layer. You see the color of it? You see the different change here? And where is it now? It's in your vital organs. Pancreatic cancer, all kinds of different cancers. They break through the membrane wall into and invade with some kind of nasty toxicity from whatever this growing thing is. And they will say it's some kind of tumor, it's this, it's that. And, you know, they could do the cell cultures on it and see basically what's going on. But what they should be looking for is the difference in the bacteria that's in these invaded cells and what bacteria resides in the non-invaded cells. You know, the ones that, not in this guy, but in somebody with a pancreas, they go for that layer and they find out what kind of chemistry is in there. And the only thing that makes chemistry, I don't care what they say, your body does it, your hormones do this, no. No, they're molecules. All right, listen to me carefully. Your body creates nothing. Zero. Zero. The only thing that creates any single thing in your body is bacteria. Good and bad. You have to have both. When your cells die off, what are you going to do? Just let them pile up in a trash heap? Someone's got to go down there and break them up and get rid of them. They're programmed from your DNA and a genetic code of life, absolutely. But they are chemicals. You do not get the chemicals without the bacteria. The bacteria are enzymes. You know what an enzyme does? Well, maybe you have never seen a protein. A protein is the most elegant molecule you could possibly imagine, and every bacteria makes an enzyme. Well, basically every bacteria. But some bacteria go out and they clean up all of the trash. But it's 100% of your biology is bacteria. In the research, that's what I'm saying. Now, does that mean do something or don't do something? No. This is research. Research only. So now, I see today, just a few minutes ago, this comes in about glycine unmasked. And that's a game changer. Now we know glycine. Everybody that's got a problem, we find glycine causing depression and anxiety. I'm just paraphrasing. I have no idea what they. I'm going to look into it though, because I'm going to tell you right now, glycine is nothing more than atoms. They're molecules. They're molecules that are constructed of all these little bits and pieces. And they have to be worked on by bacteria. If they're not worked on by bacteria, they're just not going to do what they're supposed to do and provide the chemistry to keep this layer, actively suppressing any invasion. This is going to create chemistry. It's going to create toxins that kill the ones trying to get in. And I don't think this is fully understood. I really don't. And as a matter of fact, I know it's not fully understood. And I know, for another fact, that this layer has just recently been discovered, basically. Now, I've known about this layer for a long time because I've talked to a lot of top anatomy people that do autopsies and everything. And they know about all these layers of membranes, and there is a ton of them. And this last one is what they call a fluid-filled highway. Bacteria reside in here. And bacteria, I'll probably show you, but they're single cells. You can't see them. They're tiny, tiny, but they have a little tiny spinner on the back, which is like a propeller. Spins 100,000 RPM, some of them. Zip, gone. Where's it supposed to go? To get this guy. If it's not there, that guy does whatever he wants. And again, this is called the interstitium. Let me just show you something quickly. But this here, if they're talking about glycine as an issue with anxiety and depression, that to me is the layer right here that protects your nerves. All right, for some reason your nerves are getting on edge or whatever. Believe me, I know about that. Maybe I got a problem with my interstitium. I don't know. But I can tell you one thing. Autism was how I was going to start with this today. And then I decided I'd look and make sure I could show this, the interstitium. And then I came up with the cancer. So I said, well, everybody knows about cancer. A lot of people, autism very, very, very prevalent. Now, 1 in 44 kids apparently has autism. Now, it's a spectrum. They're not all just really off the charts, but this kid was. And Marguerite, I don't know, I can't even remember how we got together. This goes back a number of years. And like I say, I don't know how, but the first thing I said, how does he poop? What's his poop like? I'm serious. This is where you got to start. If you don't digest right, your poop's not right. Case closed. So she says, all autistic kids, autism causes that. I said, no. The autism doesn't cause that. Well, see, here you go. I cannot say that. I'm saying what the research, well, let me just show you what the research does say. Because it's not been looked at, because it's an area that they're a little afraid to dig into. First of all, it's feces, and it's not an accepted treatment yet. But look at this. I'm going to show you how accepted it's going to get, and quickly. Now, like I say, I worked with Marguerite years ago, and John was nonverbal, continuous stimming and humming, and just really very, very, very bad off. And they wouldn't even take him in for a study on autism because he was so far off the chart. And she's had very good success. I'm not saying everything is 100%, but, well, let me just show you what the research says. And she has had very good results, and she ended up going to Harvard to study these tiny little bacterial interchanges, ribosomes, and all that sort of stuff that happens. And now she is teaching. Okay, as I told you, it has to break through your interstitium to get down into your healthy cells. So what does that mean? Well, here's what it means. Dubbed the interstitium. The new organ is a network of fluid-filled cavities found everywhere in your body. Those cavities I just showed you, those are membranes. Your body is lined with a network of fluid-filled membranes which have cavities. Until now, they were unknown to science. They didn't even know this. This is 2018. So, believe me, doctors are not as quick to pick up on things as you would think. Well, I'll show you the type of hits they get on their papers. I get a lot of hits, I really do. But it doesn't, they cannot speak. Well, I'll show you something. Hold on. So don't forget, 2018 is when they discovered, or they announced that they discovered it. See, 2018, they say they discovered a new human organ. They always thought it was just flat. I could see them perfectly in my mud fossils. I can see, and I worked with my friend Gil for years about this, but now they say it's all new organ, big thing about it. But let me show you something else. Now, I did get interrupted a couple of times, so I'm sure that I told you this was all supposed to be about Marguerite and her work. And when we originally started, I probably told you this, but I'll tell you again. I said to her, what's his poop like? And she said, oh, all the kids that have autism have digestive problems. The autism causes the digestive problems. I said, no, Marguerite, let's get his poop straightened out and then see what happens. Sure enough. And she's had very, very good success. I mean, it's not 100% turnaround. And what happens is autism, it appears to me, and this again is research, and that means searching. It doesn't mean shutting up and do what science tells you, because science is not 100%. Science never stops if you're a true scientist. And a true scientist, the first thing they say is they ask questions. And I'm asking questions. All right, now, here's the question. Fecal matter transplants. That fecal matter is poop. And what lives in the poop is the bacteria that break down all of the things that you eat. You cannot eat a carrot and it turns into a fingernail. It just doesn't happen. The carrot has to be broken down into its constituent components. Those are the molecules, the atoms, the little bits and pieces. And then another bacteria comes in with an enzyme and says, whoop, we got to build that stuff up to make this guy some, whatever it is, glucose or whatever it is. Muscle tissue, ligaments, joints, synovial fluids, pancreatic juices, whatever it is. If you don't have the chemistry, ain't gonna happen. That's called pre-existing condition. You do not have the correct bacteria. How can we get around this? Well, they're trying these fecal matter transplants for autism now. And it's, well, here, let me just show you. This is all within the last couple of years. And Marguerite's been working with John for, I don't know, 4 or 5 years, let's say. And look at this. These are scholarly articles cited by 26, cited by 383, cited by 10. These are their top. Nobody's paying attention to these things. Listen to this. Fecal microbiota transplant relieves these issues. Our data suggests, the data suggests, I'm not telling you to do anything, that a fecal matter transplant might be a promising therapeutic strategy to improve the GI and behavioral symptoms of patients with autism. And then it's just because of the bacteria. Now listen, look at this. Now the National Institute of Health is looking into it. Fecal matter transplant relieves gastrointestinal problems with autism. Fecal matter transplant in autism spectrum. An open-labeled study, 2-year follow-up showed that FMT is relatively safe and significantly alleviating gastrointestinal and neurobehavioral issues. Autism symptoms reduced nearly 50% 2 years after. It's still. And they always were using it for C. difficile, not for, and now they find out literally almost everything it has a benefit to. And they still don't know what these exact bacteria are. That's the key. Look at this. Long-term benefit, fecal matter transplant on autism. Long-term, promising therapy. This is just this year. Autism spectrum complex behavior disorder. And now they're saying this improves these problems. You know, can a fecal transplant reduce autism? This is all within the last year or two. 2022. A 19-year-old who was nonverbal. Now, John Jr. was nonverbal. And he was continuously stimming, that's called stimulating behavior, and humming, and apparently he was really not well off at all. And I guess a lot of those symptoms have at least significantly subsided. Because she said, anyway, it speaks for itself. You have to see, look at this, efficacy, FMT, reduced childhood autism rate, autism, gastrointestinal, fecal transplant. This is not just a one-off. This guy we actually had, I was supposed to be on a conference call. Somehow I missed it. But Marguerite and my other friend Andy, who is he's a bacterial specialist. He's got 3 PhDs and that kind of stuff. They did talk about, look, this is all within the last couple of years, 2021, 2022. I could go on for days. Now, go to the root cause, fecal matter transplant. Yeah, but what are they doing? They're putting bacteria in you, and where is it going? Into that fluid-filled highway. That's called engraftment. It has to get in there and stay in there. You can't just flush it into your colon and it's going to be, it's got to get into your interstitium. How do you do that? I'm not certain. It appears to engraft by itself, and I think it may be because there's lesions in these areas where there's breakthrough. There's lesions. So why, Roger, would that cause engraftment? Well, if you got a cut and stuff can go out, stuff can come in. So if you, like they do them, they give you basically an enema, that sort of thing, colonoscopy, and they squirt it up inside of you, somebody else's fecal matter. Literally, that's it. And then it's supposed to, and it does. And it works very quickly. And it works very well. But usually, if it doesn't engraft and stay in you, you're good for a couple of weeks. And that's why probiotics are very good. They're good. Absolutely. I think they're good. And again, this is all my opinion. I don't say take them, don't take them. They appear to be at least a minimal solution to gastrointestinal bacterial non-digestion. That's what it is. It's dysbiosis. You're not digesting your food. That's why it comes out all nasty and all kinds of problems you get when you don't have the bacteria to break down the food. A septic system works that way. Everything is bacteria. I mean, I'm talking about 100% of, well, you can mix chemicals, but when you're inside of your body, some of that stuff happens, but trust me, your bacteria is your main source of this interstitial highway. And the bacteria, like I say, they travel like a rocket ship through there. And they go all over your body very quickly. And I'm not exactly sure how quickly, but the reason I know about this is because I was working with a guy in Europe, Germany. And he said that they discovered that something in the tattoo, black stuff I think it was, they were finding it on organs. in this layer on the organs, and this is the interstitial layer. So it's got to be going everywhere. If that stuff gets a tattoo, you know how they do that. They put that little colored stuff in you, and apparently, if they hit this interstitial layer, it'll flow through you. Now, I don't know if that's normal, but I do know I looked into tattoos because of this. It's just the way I am. It's just I can't help myself. And if you don't get it just in the right spot, in the depth, they fade, they dissipate, they do all kinds of, they don't look crisp. And all your layers of, like, your face is different than your butt and your arms and your legs and your knees and your elbows. They're all different layers of tissue and membranes. And basically that's what they are, is the layers of tissue and membranes, and there is zillions of them. When you look at, well, let me show you. Okay, pay close attention to this. I mean, I'm being very, very serious today. I usually play around, not today. This is that fluid-filled highway. What is this? What are these little things? Let me come in real close. You see what they look like? Those are the factories. Those are the factories that create the chemistry of your body. And they squirt them right out there, and they take right off, and they do their job if the bacteria is there. The bacteria is not there. I don't care what you do. You can't get the chemistry. The bacteria are the chemists. Okay, my friends, this is where it all comes down to how it works. Bacteria, all right, that's a bacteria, a single cell bacteria, one cell. It has its own DNA. It knows exactly what to do. That's its program. Then it has what they call ribosomes, which are the products that it creates. Basically, think about it that way. And then those ribosomes are the enzymes. Basically, you have to think about it that way. All right, I just showed you the bacteria. The ribosomes that live in these bacteria are macromolecular machines. What does that mean? Macromolecular machines. Macro means a lot of little molecules, and it does a machine function. They're found within all cells, because every cell has a membrane, which is the thing that protects every single cell in your body, 100%. They're found within all cells that have membranes. They perform biological protein synthesis. Well, what does that mean, protein synthesis? It's mRNA translation. What does that mean? It means they make these proteins. Protein synthesis. They link amino acids. That's what ribosomes do. Now, how does that work? And can I show you that? Absolutely, I can. These are ribosomes. These are the products of ribosomes. Basically, they look like this. They're little polypeptides, and they come out in a chain. Well, hold on. All right, if you look up bacteria and proteins and enzymes, bacteria are the factories. This is the factory worker that makes one specific thing. One specific thing, and it is elegant. Now, that is the bacteria, one single cell. It has a propeller. It can go 100,000 RPMs. That is fast. And what is this? These are the polypeptide chains. These are these right here. Obviously this is just a semblance to show you what it looks like. But here's what happens. They come out. These are all the different amino acids. I believe there's 20. And they link in a certain sequence. You have to have them in a certain way or they won't bind. That's part of their beauty. Now, when they come out, squirting out of a bacteria, once they hit a certain amount, and some bacteria make 4 or 5 of them in one shot, some of them make 1 or 2 of them, another one makes just a single one. But they're all making them, and then they'll always end up doing this at the end. And they'll turn into something like really exotic. But it'll be always exactly just like that. Never any change. If there's any change to it, it's called denatured. It will not work. Now, what does that mean? Well, here's what it means. I'm just going to show you two looks at enzyme proteins. Enzymes are proteins. The little balls come out in these strings and they go, and they do it because of the attraction, the positive and negative attractions. And it creates the most elegant molecule that you can possibly imagine. Look at this. Every one of these is a positive or a negative little end that's sticking out. And what does that mean? One of these comes by and it says, hey, you got one here, 2 over here, and 6 over here, 5 over here. And it says, you know what? I do. Bam! It hooks up to it. Instantly it changes this one to do whatever that thing is programmed to tell this one to do. It's not hard to understand once you realize how powerful bacteria is. Look at this. This is beyond amazing. They just discovered this, 2018. That's that fluid-filled highway. These are the factories that create the enzymes, or the bacteria. The bacteria live in here. They create the enzymes. The enzymes, zip, go out, carried by the bacteria. Well, let me show you what they discovered, what the cells look like. It says, don't trust your textbooks. They're not right. This is what your body looks like. Watch. And this is from UC Berkeley, I think. Gokul is the guy. You see this? This goes back right to the same time frame, 3 years ago. Your textbooks are wrong. This is what cells actually look like. Crawling immune cells. Crawling immune cells, exactly what I'm talking about. And wait till you see, it looks identical to the picture I just showed you of the interstitium. Now, I don't think at this point he really understands. He's talking about they're going through eating up all kinds of different things and food in its belly. No, those are enzymes. I believe he's saying one of them doesn't eat anything, it just goes out sniffing. That's one type of bacteria, sniffing around for invaders. And the other ones eat a bunch of things, he's saying. They say, go get some of these enzymes and bring them out and then deliver them. And it goes in, out it goes. Watch. It's unbelievable. This is only going to take a minute or two. Listen to this. This guy's name is Gokul. And he's a very nice guy. And what did I do? Oh, here goes. You ready? Here goes Gokul. Take one.
I still remember the moment. It's something I will never forget. The hair on my hands just stood up. It's a microscopic universe within each cell.
Now you saw how that thing was. There's all that stuff too, yes. But now we're going to come to the interstitium. Well, into the immune layer.
This is an unprecedented view of the cellular world, where we can actually see immune cells scooping up sugars in the ear of...
Did you hear what she said? Immune cells scooping up sugars in the ear of a zebrafish. Maybe yes, maybe no. This is everywhere in your whole body, and it is a fluid-filled highway. What they're scooping up, I don't know. But I'm going to tell you what, some bacteria, maybe not this one, some of them have to scoop up all these enzymes. They got to run out and grab all these little bits and pieces, pick them up, and then watch what happens. Once it gets filled up, out it goes. And then listen to what Gokul says about 2 types of bacteria. One is a sniffer. It's a scout. It's traveling around looking for invaders. The other one does the chemistry. Watch this.
of a zebrafish in real time.
Focusing only on the crawling immune cells, we've noticed 2 classes of them. One seemed was not hungry at all, but it was very active in terms of trying to figure out,
Have you seen this before? That's this. He says it's very active, but it's not eating anything. It's looking at a sniffer. It's a sniffer.
What the environment is. There's another one that was kind of slouching around with a lot of food in its belly. We can actually conceptualize and visualize and analyze the contents of each of these cellular compartments in this crawling immune cell as it's kind of scooping up its environment.
Now, the reason he's talking about this is they developed a new technique for using microscopes that doesn't invade with all of that light. Somehow they did it. I'm not sure yet. I haven't really looked into that. I can see what they did. They're able to see these interactions with and not destroy the cells when they do. When you're on that cellular level, a single-celled organism is, you can damage it with light, no question whatsoever. And that's why they never could see them in this detail. And that's why they never even knew about the interstitium. Now they can actually see it actually happening. You saw what that cell looked like. Well, I'm going to show you again because I don't want you to miss this. This is the cell. This is the immune system cell. That's that one. And that's the fluid-filled highway. You see it? That's those cells. That's those immune cells. And they squirt their stuff right into that fluid-filled highway. This is not probably known that well by your doctors. I'm going to tell you right now, this does not float around quickly through the medical industry because everybody's afraid of getting sued. They tell you one thing wrong and you get injured because of that, well, they're in trouble. So, I'm not telling you to do anything or don't do anything. That's not my way. I say, here's what the research shows. Think of this as skin. Because even your organs have skin around them. It's just nothing more than an outside casing of tissue. And then you get down into the place that says, nobody comes down here. Nope, boop, 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 boop. This is an area where, yeah, it could probably get invaded a little bit. It happens all the time. You're going to get scuffed up here and there. But not through here. Once you come through there, and these guys can't stop you, now you got stage 1, 2, 3, 4. Your case is closed. Okay, so as I said, it's sort of turned into a free-for-all here, but everything does. There's nothing that's not connected to something else. There is nothing that stands by itself. Now, Marguerite she's being accepted worldwide here as understanding how to deal with this situation the best you can. I'm not saying everybody's going to get fabulous results. I'm not saying you're going to get any good results at all. But if you don't try, I can guarantee you're not going to get any good results. This does not just go away by itself. You have to make that chemistry work again. So anyway, she got a hold of me. She says this woman wants us to do a book review. And look, she's writing a book. So that's how this started the other day. And I said, she said she just sent it to me. And she, at the same time, had told me that this one family had no results, no good results. And they did everything. I think I already told you, fecal matter transplant, stem cells. Something's missing here. Or it can be some genetic issue, yes. I cannot rule that out. But I will say that the research does not necessarily point to that as the beginning place to look. If you could see the sequence and know that sequence, if it's here, it's okay. If it's like this, it's no good, well, then that's a different story. And if you can prove it one after the other, after the other, after the other, I don't see that being done. I haven't seen it. They may know that. They may know what kind of issue occurs when you get a certain type of cancer. But I can tell you what, there's no question whatsoever. It's breaking through these membrane walls. Tells me that you can't stop them. You have no army. You have no troops. And bacteria are your troops. Now, there's good bacteria, there's bad bacteria. Your troops are going to fight other troops. Other troops are going to be passing through your body. You're going to actually eat those other troops. Your body is going to bust them all up into little bits and pieces, and your body will consume them. Now, what happens after it consumes? Well, you got to break down all the garbage. That's called your lymphatic system, the lymph system, which is nothing more than another fluid-filled highway that drags these things around to these little nodes. and it dumps all the crap in there. And it says, all right, you take care of it. I got it here. I'm done. I'm out of here. And then the lymph node says, all right, oh man, this is some nasty stuff. Go get Bob. He's the guy that takes this kind of stuff. Whew. Everybody get away from it. And Bob comes down, he takes it out. They go to get Bob. Bob's not there. What happens? He says, you got to get Bob down here. He's not there. He said, what happened to him? Well, the guy took some antibiotics. Here's what happened to me. I had some antibiotics for a root canal that I had done, and nobody ever told me about taking probiotics. I ended up having surgery twice for what's called an anal fistula, which just breaks through the walls of your rectum. And I was fortunate that I had twice, because they never told me anything the second time either. So anyway, this is something that needs to be talked about in much more detail. And Marguerite is the one. She's the one. Here's what she says. Look, she says, I was started to worry when she said somebody wasn't getting any results. I said, are you getting some people at least getting relief? Because she was telling me she was having real good success. And I just thought, oh, well. And then when she said she wasn't getting any success with doing all of those things, I said, whoa, maybe I'm wrong. But she says, yes, Roger, I have done over 500 one-to-ones over the years as results same as John Jr., which was very remarkable. I haven't helped as many this year due to trying to get the social enterprise development up and running. She's trying to help everybody. The nurse Tara, who is joining the microbiome research, her grandson, only a few months old, and many of her family members, all results this year. All good results. Tara Business won Best Newcomer. She specializes in beauty products, no surgical facelifts, and all cosmetics linked to the best in the UK. Many of the people around the UK, she tells about us. Roger, I need a secretary. I can't help you, sweetie, to get all the emails I have sent people and collect the data. It's tough. I'm telling you right now, I struggle with it every day. I try to nibble away at it, and I know people get mad. Well, you know, I am 100% by myself. So I do what I can, and anyway. So she's, you know, there is just so much we have been building over the years, yes, and this has been several years now. So we were, and of course I said, great, this is fabulous. That's what I wanted to hear, 500 people.